Hello friends, welcome to Learner's Planet. Friends, this is our fourth session for probability. In the previous session, we discussed the problems based on balls, cards, dice. In this session, we'll be taking more problems based on probability. So let's begin the session. Now friends, let's take this problem. In a box containing 100 bulbs, 10 are defective. What is the probability that out of sample of 5 bulbs, none is defective? So in all, we have to select each bulb from this 90 non-defective bulbs, right? So we have to select 5 bulbs. So it's for the first bulb, 90 by 100, for the second bulb, 90 by 100, for the third bulb, 90 by 100, for the fourth bulb, 90 by 100, and for the fifth bulb, 90 by 100. So in all, it's 9 by 10 raised to 5, right? That means each bulb we are choosing from 90 non-defective bulbs, right? Now let's see this question. In a competition, A, B and C are participating. The probability that A wins is twice that of B, and the probability that B wins is twice that of C. Then the probability that A loses is. Now friends, here 3 persons are there, A, B, C, right? I assume that the probability of winning the race of C is X. Then probability that B wins is twice that of C, so it will be twice X. And A wins is twice that of B, that means it will be 4X, right? So total number of cases will be 4, 5, 6 and 7X. That is, and since we have to find out the probability of losing of A, so probability of winning of A is 4 out of 7, so losing will be 3 out of 7, right? I hope you are clear. Because this is a biased event, so we have to be careful about individuals' probabilities, right? Now let's try this problem. A problem in mathematics is given to 3 students whose chances of solving individuals are 1 by 2, 1 by 3, 1 by 4. The probability that the problem will be solved by at least 1. So first of all, what we do, we just find out the probability that the problem is not solved at all, right? That means none of them is able to solve the problem. Now suppose the 3 persons are A, B and C. So probability of solving by A is half. That means probability of not solving by A, that's P A bar, is also half, right? Similarly, if B solves the problem, the probability is 1 by 3. B is not solving the problem, the probability will be 2 by 3. That is 1 minus 1 by 3. Similarly, the problem is solved by C, the probability is 1 by 4. So if even P is not solving, PC bar, that's 3 by 4. Right? So sum of these two should be 1, that you should be careful. Right? Now this is the probability when A is also not solving, B is also not solving and C is also not solving. Now their individual capabilities are individual, right? Or independent, we can say. So these 3 events, when A, B and C, all of them are not solving, are independent to each other. Getting my point? So the total probability or the probability of problem not solved is what? PA bar into PB bar into PC bar. That's 1 upon 2 into 2 by 3 into 3 by 4, right? So that's 1 by 4. That means this is the probability when the problem will be not solved at all, right? It cannot be solved, right? Now the total value of the probability is 1. Out of this 1, if we deduct all the cases or the probability when the problem is not solved, so we are left with the probability of problem being solved by at least 1 person, right? So it's 3 by 4. Here, since we are asked about at least 1 person, so what we are doing, we are first of all we are calculating the problem, that problem is not solved at all. Then we are deducting this case from 1. So in the remaining cases, the problem will be solved by at least one person. It's a good concept. Just keep that in your mind. Now, a card is drawn at random from a well-shuffled pack of 52 cards. The probability of getting a heart or a diamond. Now, heart plus diamond, in all there are 26 cards. Out of 52 cards, the favorable choice is 26. So the probability is half, as simple as that, right? Now friends, this is a twisted problem. Just watch carefully. A coin is tossed 10 times. The probability of getting exactly 6 heads, right? Now, what is the probability of getting one head? That's 1 by 2, right? So probability of getting head is 1 by 2, and probability of getting not head is also 1 by 2, right? So if we are tossing coin for the 10 times, we want 6 time head and remaining times tail. That means 4 times tails, right? So suppose we are tossing the coin for the first time. Maybe we will be getting head, or will be not getting head, or will be getting tail, right? But we have to find out exactly 6 heads, right? And we are tossing the coin exactly for 10 times. That is also true, right? So what we can do is, out of 10 we can select 6 events when we are getting head, if we toss the coin, right? So out of 10 we have to select the 6 events, right? Now in 6 events, what we want to be head. So it's 1 by 2. I just write 1 by 2 6 times, right? In the remaining 4 events, we want not head, that means we want tail. So it's precisely 1 by 2 for 4 times, right? So in the 6 selected events, we are getting heads. In remaining events, we are getting tails, right? So this is the solution. So 10C6 is what? 10 into 9 into 8 into 7, or we can say it's 10C4. 10C6 is 10C4 in fact. So I simplify 10C4. So it's 10 into 9 into 8 into 7 by 4 into 3 into 2. And that's 1 upon 2 raised to 10. Right? 6 plus 4. So it's 2 raised to 10. Now we have to simplify that. So that's 7 threes are 21 into 505 by 2 raised to 9 is 512, right? So it's 105 by 512. Okay, I hope you are clear. This is really a twisted problem, but off the track. So just be very clear about it. If you are not clear, just watch the solution once again. I also make a quick recap over here. Since we want exactly 6 heads, but we are tossing the coin for the 10 times, so I am selecting 6 tosses out of 10 in which we are getting heads. So in this, the probability of getting heads in each toss is 1 by 2. So in 6 tosses, it's 1 by 2 raised to 6. In the remaining 4 tosses, we are getting tails. For each toss, the probability of getting tail is 1 by 2. So it's 4 times, because we are getting head for tail for the 4 times, right? Now just simplify it. This will be the answer. Okay. Now we have an interesting question. A speaks truth in 75% cases and B speaks truth in 80% cases. The probability that they contradict each other in a statement. Now, probability of A speaking truth is 3 by 4. That means probability of A not speaking truth, that means A speaking lie, is 1 by 4, right? Similarly, probability of B speaking truth is 4 by 5, that's 80%. And probability of B not speaking truth is 1 by 5, right? Some of these two should be 1 and some of these two should be 1. Now, if we want them to contradict each other, that means for a particular statement, if A is speaking lie, B must, if A is speaking truth, B must lie. Or if B is speaking truth, A must lie, right? So this and this, and both the events are independent, right? Now I'm sorry, mutually exclusive. So A is speaking truth, simultaneously B is speaking lie, or B is speaking truth and A is speaking lie. Okay, then only contradiction will be there, right? To state a particular statement or a fact, right? So it's this what? 3 plus 4, that's 7 by 20, right? Okay, I hope you are clear. Now, if two coins are tossed 5 times, then the probability of getting 5 heads and 5 tails. If we toss 2 coins for the 5 times or 1 coin for the 10 times, the answer will remain same, right? So if we toss 1 coin for the 10 times, the sample space will be 2 raised to 10, right? Right? Because for each toss we have two choices, that is head and tail, right? So in all the total possibilities are 2 raised to 10, or we'll be getting 2 raised to 10 combinations. Okay. Now what we want is we want 5 heads and 5 tails, right? So 5 heads and 5 tails. Now the possibilities are there, that order of head and tail is not fixed, right? Maybe head, tail, head, tail, head, tail, tail, head, something like that, or maybe we're getting another order, right? Now how do we find that in how many cases we'll be getting 5 heads and 5 tails, right? So these are the 10 events, or I can say 10 tosses. Now in other way, if we try to understand that this is a 10 letter word, just listen to me carefully. So we have to rearrange all the letters to make different words, right? And here H is repeated for the 5 times and T is repeated for the 5 times. So we have to ignore the repetition, isn't it? So how can we rearrange these 10 letters? So it's what? 10 factorial by 5 factorial, because H is being repeated for the 5 times, as we have already discussed in our permutation combination sessions, that how can we make the arrangement if a repetition of letters is there, right? So here H is being repeated for the 5 times, so I take 5 factorial or divide by 5 factorial. Similarly, for tails I divided by 5 factorial. So these are the cases when we'll be getting 5 heads and 5 tails, right? Because the head at first place and head at the second place, we do not consider them the different arrangement. That's why we are dividing it by the repetitions, right? Now what is the sample space? That's 2 raised to 10. And what is the favorable events? That is 10 factorial by 5 factorial into 5 factorial, right? So just solve it. It's, I just write it over here, it's 10 into 9 into 7, 8 into 7 into 6 into 5 factorial by 5 factorial into 5 factorial, right? So it's cancelled. Now it's 5 into 4 into 3 into 2, so it's 5 2s are 10, right? It's 4 2 and it's 3 3, right? So it's 2 raised to 10 in the denominator, and in the numerator we have 3 into 2 into 7 into 6. So 3 into 7 into 2 into 6. So it's 2 into 3 into 2, right? So it's 2 into 6. Now it's what? 2 and 2, that's 4. So I just deduct 4 from here, or divide it by 2 raised to 10. So it will be 2 raised to 8, right? So it will be 7 3s are 21. 21 into 3 is 63 by 2 raised to 8, right? So 2 raised to 8 is actually 256. So it's 63 by 256. Our answer will be, right? I hope you are clear. The problem is bit twisted, bit difficult also initially to understand, but if you just concentrate on the concept, you'll be able to get it, right? Now, What is the alternative method to do this problem? If two coins are tossed 5 times, then the probability of getting 5 heads and 5 tails, right? In all, we are tossing a single coin for 10 times, right? So what I do, I choose 5 tosses in which we are getting head, right? In the remaining, definitely we must be getting tails, right? So for 5 out of 10, 5 events in which we are getting heads, and give probability of getting heads for 5 times is 1 by 2 raised to 5. Similarly, remaining 5 times we are getting tails, so the probability is 1 by 2 raised to 5. Now we just have to simplify that. It's 1 upon 2 raised to 10, right? So it's this 2, it's 2 raised to 9, then this 3 and this 2 raised to 8. So it's 7 3s are 21, 3s are 63 by 2 raised to 8, that's 256. Right? So alternatively, you can go for this method. I hope you are clear. Now let's try this problem. A bag contains 5 white and 3 black balls. 4 balls are successively drawn out and not replaced. The probability that they are alternately of different colors. Now the combinations or the arrangement will be white, black, black, or black, white, right? Because we have to draw the balls of different color alternately, right? Now the balls are not replaced. That means the first ball is coming out of 8 balls, and the second ball is coming out of 7, and the third one is from 6, and the fourth one is from 5, right? So we have to be clear about it, right? So first of all, I just consider this case. So we have 8 balls. So what is the probability of getting white ball? That's 5 by 8. Into the second ball will be should be black, and it will come out from the 7 balls because one ball we have already drawn. So it's 3 by 7. Similarly, the third ball is white ball. Now we have 4 white balls only, and in all we have 6 balls, so 4 by 6. Similarly, now we have just 2 black balls, and in all the total number of balls is 5, so it's 2 by 5, right? So this is this case, or we can have B black, white, right? So first we are drawing a black ball. So it's 3 out of 8 into, now we have to draw white ball, so it's 5 by 7. Then further we are drawing black ball, so it's 2 by 6, right? Because one black ball we have already drawn over here. Now we have to draw white. Already we have drawn one white ball, so we are left with 4 now. So it's 4 by 5, right? So it's 8 7 6 5, 8 7 6 5, and in the numerator we have 2 3 4 5, 2 3 4 5. So 2 times 2 into 3 into 4 into 5, right? So that we have to solve. So it's 5, 2 3s are 6, 4 2s are 8, so we are getting 1 by 7, right? So quite an interesting problem, and I'm sure you are getting it. Now let's try this question. A bag contains 3 black, 3 white and 2 red balls. One by one, 3 balls are drawn without replacement. The probability that the third ball is red. Now friends, we have like 3 balls, 3 black, 3 white and 2 red balls. I just explained this problem as a arrangement of letters in a word. So it's black 1, black 2, black 3, white 1, white 2, white 3, red 1, red 2, right? This is the total number of letters. This is 8, right? Now we have to rearrange them and we have to make three-letter word, right? Just listen to me very carefully. We have to make three-letter word. Now, how many three-letter words can be made out of this? So the total is, for the first place we have 8 choices, for the second place we have 7 choices, and for the third place we have 6 choices, since we don't want the repetition. So these are the total number of cases, right? So now, what are the favorable cases? In that we want the third um, place. That means for the third place we just have two choices, that either red 1 should be there or red 2 should be there, right? So I just mark it over here. For the third place we have two choices and one we are keeping it over here, and for the second place we have 7 choices, and for the third place we have 6 choices, since we don't want the repetition, right? Because we want the third ball to be red. So for the third place we just have two choices, right? So these are the favorable cases when we want the third ball to be red, right? So it's 6 into 7 into 2. So that's 1 by 4, right? So it's 1 by 4. Okay, I hope you are clear. Or you can make the various combinations also, that's black black, red white, black red, but that will be a lengthy process. This is some what easy process, and like can be done in short time. Now, in this question, 7 balls are drawn simultaneously from a bag containing 5 white balls and 6 green balls. The probability of drawing 3 white and 4 green balls is. Now, in all, we have 5 plus 6, 11 balls, and we have to draw 7. So, the denominator will be 11C7, right? And out of this we have to draw 3 white and 4 green. So how many whites are there? It's 5 white. So out of 5 we have to draw 3. So it's 5C3 into, we have to draw 4 green. So it's 6C4 by 11C7, right? So this is what our answer is. So it's 5C3 is 5C2 and 6C4 is 6C2. So this is the correct answer. Okay, don't have to solve it. Now in this question, out of 15 persons, 10 can speak Hindi and 8 can speak English. If 2 persons are chosen at random, then the probability that one person speaks Hindi only and other person speaks both Hindi and English. Now the total number of persons are 15 and 10 are speaking Hindi and 8 are speaking English. So in all this is 18, 10 plus 8. That means 3 persons can speak Hindi as well as English, right? So if you wish, I can draw a Venn diagram over here. It's like this. It's Hindi, it's English. So 10 plus 8, 18, and total number of persons are 15. So 3 are counted 2 times. So this is what? 3, right? Now in the Hindi circle there is total 10. So 3 over here. So 7 will be here. So it's 7 and 3, 10, and this 5, right? Now we have to choose 2 persons. One person speak Hindi only and other speak Hindi and English as well. So total choice is 15C2. 1 for the first person, or for the one person we have for Hindi only we have 7 choices. So I just, instead of doing this, I choose the first person as only Hindi. So that's 7 by 15. And the second person as Hindi and English both as well. So that's 3 by 14, right? Into 2, because the first person may be of Hindi and English both, and the second person may be Hindi only, right? So this is 1 by 5, right? I hope you are clear. Now, the pair of fair dice is thrown independently 3 times. The probability of getting a score of exactly 9 twice. So we want 9 to be 2 times, right? Now, how many chances are there of getting 9? So it's how many combinations when we are getting 9? So it's 4, 5, 5, 4, 3, 6, and 6, 3, right? So for a single pair, we have 4 combinations when we get 9 out of total 36 combinations, right? Total combinations are, or the sample space is 36, right? So if we throw the dice for once, so the probability of getting the sum as 9 will be 4 by 36, right? Now we have to get 9 two times, exactly 2 times, right? So suppose these are the 3 cases, right? It's 9, it's 9, and it is non-9, or I can say false, right? So this is a 3-letter word in which that we have to rearrange, right? Because chances are that we are getting 9 for the first time, not 9 for the second time, and 9 for the third time, or maybe we are not getting 9 for the first time and we are getting 9 for the second and the third time. That means 9, 9 and not 9, that is false 9. This is a 3-letter word which we have to arrange. So a 3-letter word in which n is repeated can be arranged in 3 factorial by 2 factorial. That's 3 ways, right? Okay. Or else we can think, see, if we are throwing the dice for the 3 times, we want 9 to be for 2 times. So the combinations of getting 9 for the 2 times is 3C2, right? Now 3C2 is the total number of combinations when we'll be getting 2 times 9, right? Now for the remaining third time, any other sum can be there. Right? Now there are total 36 choices. So for the first throw, or for one throw, the probability of getting 9 will be 4 by 36. For the second throw, or for the other throw, the probability of getting sum as 9 is 4 by 36. For the third throw, we don't want a 9, so it will be 32 by 36, right? The order can be rearranged, that we already have taken care over here. That's 3C2, right? So the order can be rearranged. Now it's what? 3C2 is what? 3 into this 1 by 9 into 1 by 9 into 8 by 9, right? So it's 8 by 243, right? I hope you are clear. Now friends, let's say this problem. A person draws out 2 balls successively from a bag containing 6 red and 4 white balls. The probability that at least one of them will be red. So what we do is we draw both the ball to be white, and if we deduct it from one, so in the remaining cases at least one ball will be red, right? So in all there are 10 balls, 6 plus 4. So out of 10 we have to draw 2 balls, that's 10C2. And what are the favorable events? That's out of we are drawing both the balls as white, so it's 4C2, right? So that's 4 into 3 by 10 into 9, so it's 2 by 15, right? So 2 by 15 is the probability that none of the ball is red, right? So if we deduct it from 1, so in the remaining cases at least one ball will be red, right? So that's 13 by 15. So that's 13 into 6, 15 into 6, that's 78 by 90, right? Friends, will be taking more problems in the next session. Bye-bye.